Hello everyone. Today we are going to discuss the fifth problem of AtCoder beginner contest 336, which is digit sum divisible. So what is the problem? So we are given some positive integer n. A good integer is defined as a integer which is divisible by sum of its digits. So you can check that 2024 is divisible by 8, which is sum of its digit. So it is a good integer. So you have to find all good integers which is less than or equals to n. So the limit on n is 10 to the power 14. So how we can solve this problem, right? So I'm not going into explaining the examples because the examples are quite straightforward. Any integer which is good, which in which sum of the digit of the integer divides the integer itself. So you can check this 13 integers, sum of their digits divides themselves, so there are 13 good integers less than equals to 20. Okay, I hope you get it. Now how we can solve this problem? So for solving any problem like this, we have to think about iterating over digits and doing some recursion, which is called digit dp, right? I hope you all know something about digit DP. If you don't know about digit DP, I will try to explain it what it is. So in digit DP, we will iterate over each of the digits and we will try to find the answer, right? So we will try to construct a number by iterating over digits. So what could be our possible states, right? So let's say we have taken the first digit as 1. We have taken the first digit as 1. Now at the second move we can take the second digit as 2, and at the third move we can take third digit as 3, right? So what could be our recursion state variables? So what could be recursion state variables? One is like we have to take the sum of the digits and the remainder. Okay, so the two things I can clearly observe is, one is the sum of the digits and another one is obviously the remainder modulo sum of the digits. Remainder modulo sum of the digit. Now these are the two things: remainder modulo sum of the digits, sum of the digits, and another thing is the length of the integer. And the thing is the length of the integer, you can call it as L. Here I am calling it as I. Okay, or length. Here I am calling it as length. Okay, so these are three important variables. Now uh, here how we can get remainder, right? How we can get remainder if we don't know some of the digits previously, right? So here you can check that we are adding 1, then we are adding 2, and then we are adding 3, and some of the digits is getting changed. So we can't really know this value, SOD value, right? Because SOD is in our recursion state. So what we can say is that, as SOD in our recursion state, we can't really identify the sum of the digits value, so we can't really identify remainder, right? So for that we will take another parameter in our recursion state. We will call it as original sum of the digit. So after our constructing the number is done, it should be that sum of the digits should be equals to the original sum of the digit, and instead of taking the remainder modulo sum of the digits, we will take remainder modulo original sum of the digits. So these four are the most important parameters of the recursion. So here we have, let me write it in more appropriate order. This will be length, remainder, sum of the digits, and original sum of the digits. Original sum of the digits. Now there could be some extra parameters because we have to construct the number which is less than equals to n. So here you can see that if the n is 113, then for the second index we can't really take 2. We have to take either 0 or we have to take either 1. So we can take 1 0 or 1 1, but we can't make it as 1 2. So we will take another variable f flag, which will determine that if until the current index, length, our number is already lesser than our n, or it is equals to n. So let me explain. So here let's say our number n is 113. Now we have taken 1 as our first value, and at the second value we can take 1 0 or 1 1. Now when we are doing 1 0, we can take any number from 1 to 9 at the third index. It could be right 1 0 1 102 or 109, or it could be either 100 also. But when we are doing 11, we can't really make it as 118 or 119 or anything greater than 113. So here then flag will be our 0 because we can take anything, but here our flag will be 1 because we can only take up to 3. Okay, so that's what flag means, right? So we have 5 variables. Now I will also take one extra parameter that will help us solving the problem, that is our flag. You can take it as flag or you can take it as leading zeros. Okay, so we can't really take leading zeros because let's say we have taken 0 1, it will definitely will give same answer as 1, so we will count duplicates. So instead we are taking 0, non-zero you can say. So non-zero means that we have already taken some value. So instead of taking this 0, I think I could have done it better by checking that if length is greater than 0 or not, or something like that. But instead of that I have taken 0. Okay, I don't think I can check it from length because I am decrementing the value of length, and I don't really have the proper value of length, right? So we don't really know at a recursion state if we have taken something at the previous index or not. That's why I am taking something some flag as 0. 0 means that we have taken an integer or not previously. So at first our 0 value will be 0, and after the first operation is done our 0 value will be 1. Okay, so that's what 0 means. So here let's don't call it as 0, instead of call it as flag. So for the first index our flag will be 1, and for the rest of the index our flag will be 0. Now if our flag is 1, we can take from 1 to 9, but if our flag is 0, we can take 0 also. So we have 6 parameters of our recursion. The first parameter is length. Length could be from 1 to 15 because the maximum value of length n is 10 to the power 14. What is the number of digits in n? 10 to the power 14. There are 15 digits. So length could be 15. And what could be the maximum value of remainder? So we are taking remainder modulus SOD. So let's first identify what is the limit on SOD. So SOD could be like for 10 to the power 14 the SOD is 1, but what could be the maximum value of 10 SOD? Yeah, from 0 to 10 to the power 14, it is nothing but 9 into 14, because if we take 14 nines, then we will get maximum SOD. So 14 into 9 is nothing but 126. So the constant on SOD is 126, constant on remainder is 126, constant on one original SOD is also 126, and these two are just boolean flags. So would take two values. Okay, it would take two values. So if we want to optimize the space, you can take it as some bit also, because we're just flipping the bit. Okay, so now I'll try to explain the recursion transitions. So let's say we are at something like length, remainder, SOD, original SOD, if and flag. So I have already explained what if does and what flag does. Now if our flag equals to 1, if our flag equals to 1, then we can take from 1 to 9, and if it is flag is equals to 0, we can take from 0 to 9. So you can see that we can take from flag to 9, right? We can take flag to 9. Now we can't really take up to 9 because we have also one flag if. So if is enabled, then we can only take from up to SI. Okay, let or you can call it as NI, the index ith index of n. So if is equals to 1, we can the maximum value we can take it is ni, and else our maximum value we can take is 9. So I hope you got the what flag and if signifies. Now we will jump into the transitions. So we are at some state, let's say length, remainder, SOD, original SOD, if and flag. So we will iterate over every possible length, right? We will iterate over every possible length from 1 to 15, 1 to 15, and we will also iterate over all the possible values of SODs. SOD could be from 1 to 20, 0 to 126, right? So I think 0 is not possible because the remainder is modulo SOD. So the minimum value of SOD is 1. So we'll iterate over all the possible values of length and all the possible values of SOD, and the rest of the parameters will be 0, right? 0. Now the value of f. Now if we are taking any length which is less than equals to n's length, so let's say length of n for 113, the length of n is 3. So here you can see that if we try to construct any integer which is lesser than the length of n, the flag value f value will be 0, because like 113 we can take anything, right? We can take 99, 98, anything. We can take anything from for the first and second index. So that's why our flag value will be 0. Sorry, yeah, the flag value will be 0. And for the other cases the flag value will be 1. Sorry, f value will be 1. So uh, forgive me because I am using if and flag interchangeably, but they are two different flags, or you can call them as flag 1 and flag 2. Now how the remainder value will be changed? Let's say we have taken some digit d. Okay, so we have some taken some digit d at length l, length. So here you can see, let's say we have taken 1, right? So what is the contribution of 1? We have taken 1 at length 3, right? We have taken 1 at length 3. The contribution of 1 will be nothing but 10 to the power 3 minus 1. So 10 to the power length minus 1 will be the contribution. So when we are taking some digit d, we will do what? We will do remainder plus 10 to the power length minus 1 into digit, and we will do this by modulo original SOD. This will be the new remainder value. Let's call it as NR. Now what will be new SOD value? New SOD value will be nothing but the previous SOD value plus the digit, and length value will be the change of length will be nothing but length minus 1. Now, and the changing the value of if and flag, I have already explained that if we are taking something non-zero, then the flag value will be changed to 1. So now let's jump into the code. You'll understand it better. So here I am taking the input as n, and I am putting every digit of n in a vector because we will access it. So and for every value, every possible value of length, we are just iterating on length. So I will determine our length, okay, and j will determine sorry, I think j will determine our length, and I will determine our original SOD. So we are calling recursion on length equals to j, and is remainder and SOD as 0, and our original SOD as I, and our flag value as 0, and our if value, or you can call it as flag 2, as j equals to v dot size. If v dot size, I have already explained, if we have taken length as 3, we have to consider this case. So that's why if the length is 3, then our if value or flag 2 value will be 1, otherwise our flag 2 value will be 0. Now let's jump into the recursion part. Now if our current sum of digits, or ds, sum of digits is greater than the original sum of digits, so we just return 0. We don't have to check anything, we'll just return 0. Now if length equals to 0, that means our constructing of the integer is done. We'll check if the remainder is 0 and the sum of the digits is equals to original sum of the digits, okay. And this part is for memorization, so we don't consider this case. Now if flag 2 or if is not set, we'll take from every value from 1 to 10. We'll take any value from 0 to 10, and we will obviously take not flag. I have already explained to you that what we are doing. If flag equals to 0, we are taking from 1 to 9. I think this will be 0 and this will be 1. If flag is 0, we will just iterate from 1 to 9. Here it will be from 1 to 9 if flag 2 is not set. And we are doing the recursion step. I have already explained, length will be decremented by 1, and we are taking remainder, and power of length minus 1 will determine 10 to the power length minus 1. I am doing some pre-calculated calculations to avoid calculations in the loop itself. uh, and similarly we are changing the value of current sum of digits, and we are changing the value of flag also. And if is already flag 2 is already 0, so we'll give it as 0 in our next step also. Similarly, if flag is equals to 1, flag 2 is equals to 1, we can take up to v of length minus 1. So here you can see that we can take only up to 3 for the third index. If we have taken 11 up to the second index, so we can take up to 3 in the third index, right? So we are just iterating from not flag to v length minus 1, and the rest of the transitions is quite simpler. So instead of doing this if and else and doing two loops, you can just change the lower and upper bounds, and can do it in a single loop also. Okay, and we are at the end, we are storing the value in our dp array, and we are returning our answer. So I hope I am able to explain the digit dp part to you. If you have any doubt in any part of the video, you can always write in the comment section. I will try to reply each and every comment. If you find this video helpful, please like the video and subscribe to my channel. Thank you.